Hello my dear friends, welcome to our YouTube channel ADC Maths. In this class, we are going to continue the Lagrange's linear equations by using the method of multipliers technique. So how to solve the Lagrange's linear equation? So this is the problem number 2. X into y squared minus z squared into p plus y into z squared minus x squared into q is equal to z into x squared minus y squared. So this is in the form of pp plus qq is equal to r, that is the Lagrange's linear equation type. And the corresponding auxiliary equations dx by capital P, that is x into y squared minus z squared, is equal to dy by q, that is y into z squared minus x squared, and finally dz by r is z into x squared minus y squared. So this is my auxiliary equation. Once again, see the denominators in the ratios star equation all mixed up together, x, y, z, x, y, z, x, y, z. So the grouping is not that much very easy job. So let's try to use some of the techniques. In this problem, I am going to apply the method of multipliers technique. But when you choose set of multipliers, before going to that, let us consider the degree of the terms. So let us see that each denominator sides of the ratio, here h to the power 1, but these two are power degree 2, that is the degree is 2. Similarly here y to the power 1, but the other twos are degree 2. The third one is to the power 1, the other two degrees are 2. So first of all I want to make the same degree, the equal degree, then only the method of multipliers works. So what can I do? I suggest you that to make the uniform degree, the equal degree, so the best way I can make this one more x. So this becomes x squared. I can multiply one more y with this becomes y squared. I can multiply this with z, this becomes z squared. So that each one having the equal degree. So the maintenance of homogeneity, it is there fulfills. So automatically the cancellation is possible. So I can choose the first set of multipliers as x, y, z. So choose the first set of multipliers as x comma y comma z. Okay, in the star equation, in the auxiliary equation, each ratio. So once again repeat that this is the ratios concept. So each ratios are equals to, is equal to. Let us multiply x with the numerator of the first ratio. The number becomes x squared, y squared minus z squared. When you multiply the middle one with the y, then the number becomes y into y squared, z squared minus x squared. When you multiply with the z, the third ratio, I am getting that z squared into x squared minus y squared. Now, the denominators are in equal degree. So let us see, method of multipliers says that the denominator, to make the denominator is equal to 0. So when the denominator becomes 0, let us choose the multipliers, it is a one idea. Then let us make the denominators the second idea. So let us see the terms of the denominators, x squared y squared. Here x squared z squared minus n. Where we have x squared y squared, I think so when we multiply this we get it is minus x squared y squared. So when we add these two, x squared y squared will cancel. Similarly, here we have x squared z squared minus 10. Here we have plus x squared z squared, so get cancelled. So addition is the easiest way. So when we add the numerator as well as denominator is equal to some constant alpha, each ratio is equal to x dx by x squared y squared minus x squared z squared plus y dy by y squared z squared minus x squared y squared plus z dz by x squared z squared minus y squared z squared is equal to alpha. Now see that plus x squared y squared, here minus x squared, cancel, right? Minus x squared z squared plus x squared z squared get cancelled, and finally plus y squared z squared minus y squared z squared get cancelled. So each ratio is equal to x dx plus y dy plus z dz by denominator is equal to 0 is equal to some constant alpha. So by cross multiplying. So these are ratios. These are numbers. Numbers means anything by 0 is infinity, but these are ratios. So Numerator is x dx plus y dy plus z dz. It's already grouped. It's already grouped. See that? X first term, y is the second term, z term third one. So it is already grouped. But denominator is 0. Let's cross multiply next side. Each ratio is equal to, we get x dx plus y dy plus z dz is equal to 0. So once the denominator is equal to 0, then right answer is 0. Then they do the integration. Here I am getting that x squared by 2 plus y squared by 2 plus z squared by 2. Otherwise equals some constant a squared by 2 or a. So this is my first independent solution with the help of first set of multipliers x, y, z. It's clear? Isn't it? So I found that the first solution with the help of x, y, z. I need the one more. So how to choose the second one? Yes, the first one I can make the equal degree so that cancellation is very simple. Now the second set is, once again, looks the star equation. It is looks like x to the power 1 y squared minus z squared. So 1 is degree 1, the other terms are degree 2. So that's why in the last case I multiply x, y, z to make the uniform degree. But this time I can choose the different manner. I don't want this x in the denominator, this y in the denominator, this z in the denominator. So what's mean that? That means that we divide 1 by x, 1 by y, 1 by z. So what happened? When I divide this by x get cancelled. So what's the balance? Y squared minus z squared. When I divide this by y, there is no y at all, only z squared minus z squared. So this is plus y squared, this is minus z squared, plus z squared, get cancelled. So the second set of multipliers is nothing but, the second set of multipliers nothing but 1 by x, 1 by y, 1 by z. 1 by x, 1 by y, 1 by z. So now each ratio is equal to, let us see that this x get cancelled at the same time. The numerator I am getting 1 by x. So that means that we multiply 1 by x the numerator, 1 by x the denominator. When I multiply 1 by x the numerator, 1 by x the denominator, so from the denominator side that x get cancelled. At the same time we get 1 by x the numerator. Similarly, when I divide by 1 by y with the middle variable, middle ratio, then this y get cancelled. So there is no y at all. Is right? And finally the third ratio, can we divide by 1 by z? So 1 by z into dz. So this z can be eliminated. So now it is very perfectly equal. This is in perfect order. Everything is degree 2. Y squared minus z squared. Z squared minus x squared. X squared minus y squared. It's equal to some constant I named as beta. Is right? Is right? Now let us see that each ratio is equal to 1 by x into dx by y squared minus z squared. Now see that my aim is to make the denominator 0. Once again, plus y squared here, minus y squared here. So when we add, we get 0. Minus z squared plus z squared, when we add, we get 0. The way we get the 0 by adding all the 3. So 1 by x dx plus 1 by y dy. So when we add in the ratios, we can do addition both the numerator wise as well as denominator wise. So when we add the numerators, denominators becomes y squared minus z squared plus z squared minus x squared plus x squared minus y squared is equal to some constant beta. Is right? Now let us see the denominators of this ratio. Each ratio is equal to minus y squared plus y squared will cancel, plus x squared minus will be cancelled, and finally z squared is also will cancel. So each ratio is equal to 1 by x into dx plus 1 by y into dy plus 1 by z into dz all divided by 0 is equal to some constant beta. This is the ratio. Once again repeat, this is the ratio, not the numbers. The numbers only anything by 0 becomes infinity, but this is the ratios. So numerator is 1 by x dx, 1 by y dy, 1 by z dz in addition form. Denominator is 0. So 0 into the beta term, because every ratios is equal to some constant. They are in some ratios. So when I multiply the 0 to the next side, this becomes 0. So by that way, I am getting that 1 by x dx plus 1 by y dy plus 1 by z dz is equal to 0. So now the left hand side is now grouped. So once they are grouped, then we go for the integration directly. What is integral dx by x? Log x. Integral dy by y? Log y. Integral dz by z is log z. So that I can choose the constant is also in terms of log. With the help of the properties, the multiplication theorem in the there is a logarithmic side, is known as the addition theorem as well. Here log x plus log y is equal to log xy, otherwise log x plus y. Now, what is log m plus log n? Log m plus log n is equal to log m into n. Here log x plus log y plus log z. It is known as the addition theorem in the logarithmic side. So, it is log of xyz is equal to log b. After cancellation of log on both sides, we get a second independent solution. Xyz is equal to some constant b. So, this is the way to find the general solution of the Lagrange's linear equations by using method of multipliers technique. Thank you.